Hello, my name is Ross Lauber. This is my Week 3 presentation on rootkits for CSC 333. So what is a rootkit? A rootkit is generally a malicious piece of software that runs at the kernel level or user level of your system. The kernel level is the lowest level which your operating system runs at. Sometimes rootkits are disguised as drivers, so that kind of gives you an idea of how low level the rootkits can be. The user level is the application level where you see other applications, like your files and your documents, for example. Because rootkit is at such a low level sometimes, it is generally undetectable by antivirus softwares and other things like task managers. What's the difference between the kernel level rootkits and the user level rootkits? The user level runs on the same level as other applications. When used in malicious purposes, it's meant to be hidden so you can't really see it. It uses processes like DLL injection to go undetected from antivirus softwares in the task manager to see what processes are running. It gets bypassed by the kernel mode API, so if you found the user rootkit file location, you could delete it through that way. The kernel level rootkit operates at the lowest level, between your hardware and software, where your operating system is located. A con to the kernel level rootkit is that it requires system administration to install. Sometimes they're disguised as drivers, so the user thinks they're downloading something that is useful to them. Once downloaded, it's pretty hard to detect. The kernel level rootkit boots up with the operating system, so it can be pretty hard to delete as well. Some rootkits go even further into corrupting the motherboard, which completely compromises the whole system. As a process used by rootkits to mask themselves. Generally, hooking is used by the kernel level rootkits. Hooking is a pretty broad term and has many subcategories, of which the System Service Descriptor Table hooking or SSDT hooking is one example. The blue box represents the SSDT, the red box represents the malware, and the green box represents the user output. When the user requests for information, the SSDT provides it. If the information is denied by the malware, it will send back false information. If it is accepted, it will send back the correct information to the user. However, this is how rootkits hide themselves from antiviruses. Rootkits will give false information to antivirus to show that they can be trusted. DLL injections are used by user-level rootkits. It means that legitimate information requested from the user gets intercepted by the rootkit, and then it will return malicious information. The DLL will first alloc space to the call by using virtual alloc EX from the Microsoft API, and then it will write to the process memory location of the running process. Finally, the allocated DLL code is called and ran by using the create remote thread API. Then when this process happens, they can manipulate the data the user sees or run other files or code. This allows it to go undetected from antiviruses, making rootkits extremely hard to detect or to remove. I haven't really talked much on what rootkits can do to your system other than being very well masked, but they're probably the worst firmware malware you can have. They can keylog your information, they have remote access to your computer, so with this, they can steal your identity or even your credit card numbers. Kernel rootkits are hard to write to because they're at the operating system level, which calls for a lot of bugs, which isn't good, especially at the operating system, which could potentially harm your system. This is another negative for kernel rootkits because this is how they are easily discovered when there's a problem with your system. They can also have a dual purpose and serve as a useful driver while also being a rootkit. Example of non-malicious rootkits and other rootkits. In the book, it gave an example of the University of Rutgers downloading a rootkit on a cell phone. The abilities that they were able to do were track where the user was, block cell phone calls, kill the battery in case they wanted to make sure the person that needed help couldn't get help, intercept text messaging, a lot of other things. They claim that the UI was generally the same and it went undetected from the original UI of the cell phone. And they were allowed to load it onto the cell phone's operating system, which surprised me most because I thought rootkits could only be on Windows or Linux or Mac OS, but it didn't matter. And then another example of where rootkits could be useful is in the business industry. Say you wanted to hide data from a public user group or something like that, you could store it at the kernel level. Or you can control over all other systems, which can give you benefits if you'd perceive it as that. This ends my presentation here. Thank you for listening in. I hope you learned something. Goodbye.